Electronic and digital music technology is the use of electronic or digital instruments, computers, electronic effects units, software or digital audio equipment by a musician, composer, sound engineer, DJ or record producer to make, perform or record music. The term usually refers to the use of electronic devices, electronic and digital instruments, computer hardware and computer software that is used in the performance, playback, recording, composition, sound recording and reproduction, mixing, analysis and editing of music. Music technology is connected to both artistic and technological creativity. Musicians and music technology experts are constantly striving to devise new forms of expression through music, and they are physically creating new devices and software to enable them to do so. Although in the 2010s, the term is most commonly used in reference to modern electronic devices and computer software such as digital audio workstations and Pro Tools digital sound recording software, electronic and digital musical technologies have precursors in the electric music technologies of the early 20th century, such as the electromechanical Hammond organ, which was invented in 1929. In the 2010s, the ontological range of music technology has greatly increased, and it may now be electronic, digital, software-based or indeed even purely conceptual. Education. Professional training. Music technology is taught at many different educational levels, including college diplomas and university degrees at the undergraduate and graduate level. The study of music technology is usually concerned with the creative use of technology for creating new sounds, performing, recording, programming sequences or other music-related electronic devices, and manipulating, mixing and reproducing music. Music technology programs train students for careers in, sound engineering, computer music, audiovisual production and post-production, mastering, scoring for film and multimedia, audio for games, software development, and multimedia production. Those wishing to develop new music technologies often train to become an audio engineer working in R&D. Due to the increasing role of interdisciplinary work in music technology, individuals developing new music technologies may also have backgrounds or training in computer programming, computer hardware design, acoustics, record producing or other fields. Use in music education. In the 2010s, electronic and digital music technologies are widely used to assist in music education for training students in high school, college and university music programs. Electronic keyboard labs are used for cost-effective beginner group piano instruction in colleges and universities. History. Early pioneers included Luigi Russolo, Halim El-Dav, Pierre Schaeffer, Pierre Henry, Edgard Varèse, Karlheinz Stockhausen, Akutaro Kakehashi, and King Tubby. Music technology has been and is being used in many modernist and contemporary experimental music situations to create new sound possibilities. Synthesizers and drum machines. A synthesizer is an electronic musical instrument that generates electric signals that are converted to sound through instrument amplifiers and loudspeakers or headphones. Synthesizers may either imitate existing sounds, instruments, vocal, natural sounds, etc., or generate new electronic timbres or sounds that did not exist before. They are often played with an electronic musical keyboard, but they can be controlled via a variety of other input devices, including music sequencers, instrument controllers, fingerboards, guitar synthesizers, wind controllers, and electronic drums. Synthesizers without built-in controllers are often called sound modules, and are controlled using a controller device. Synthesizers use various methods to generate a signal. Among the most popular waveform synthesis techniques are subtractive synthesis, additive synthesis, wavetable synthesis, frequency modulation synthesis, phase distortion synthesis, physical modeling synthesis and sample-based synthesis. Other less common synthesis types include subharmonic synthesis, a form of additive synthesis via subharmonics used by mixture trautonium, and granular synthesis, sample-based synthesis based on grains of sound, generally resulting in soundscapes or clouds. In the 2010s, synthesizers are used in many genres of pop, rock and dance music. Contemporary classical music composers from the 20th and 21st century write compositions for synthesizer. The development of the modern synthesizer was spurred on by the invention of the miniaturized transistor in 1947. The lightweight transistors made it was possible to make synthesizers much more portable and complex. A new breed of synthesizers appeared, mainly in America. American inventor Robert Moog's synthesizer designs in the 1960s were a significant advancement in the field over its predecessors. This was partially owed to new technologies that became available, such as the newly developed semiconductors. These new instruments were less expensive and became available worldwide. These were capable of producing a vast range of complex sounds. Later versions often incorporated automatic rhythm units, called drum machines. They had more popularity than any synthesizer from the past. The release of Wendy Carlos' album Switched on Bach in 1968 brought Moog's synthesizer to the general public's attention. The album demonstrated that besides creating strange sounds, the synthesizer could be used to make beautiful music. In the 1970s, the American domination of the synthesizer market was relinquished to the Japanese, with synthesizers made by Yamaha Corporation, Roland Corporation, Korg, Kawai and other companies. Yamaha's DX7 was one of the first mass-market, relatively inexpensive synthesizer keyboards. The DX7 is an FM synthesis-based digital synthesizer manufactured from 1983 to 1989. It was the first commercially successful digital synthesizer. Its distinctive sound can be heard on many recordings, especially pop music from the 1980s. The monotimbral, 16-note polyphonic DX7 was the moderately priced model of the DX series keyboard synthesizers. Over 200,000 of the original DX7 were made, and it remains one of the best-selling synthesizers of all time. The most iconic bass synthesizer is the Roland TB-303, widely used in acid house music. Other classic synthesizers include the Moog Minimoog, ARP Odyssey, Yamaha CS80, Korg MS-20, Sequential Circuits Prophet 5, Fairlight CMI, PPG Wave, Roland TB-303, Roland Alpha Juno, Nord Modular and Korg M1. Drum machines. A drum machine is an electronic musical instrument designed to imitate the sound of drums, cymbals, other percussion instruments, and often basslines. Drum machines either play back pre-recorded samples of drums and cymbals or synthesized recreations of drum, cymbal sounds in a rhythm and tempo that is programmed by a musician. Drum machines are most commonly associated with electronic dance music genres such as house music, but are also used in many other genres. They are also used when session drummers are not available or if the production cannot afford the cost of a professional drummer. In the 2010s, most modern drum machines are sequencers with a sample playback or synthesizer component that specializes in the reproduction of drum timbres. Though features vary from model to model, many modern drum machines can also produce unique sounds, and allow the user to compose unique drum beats and patterns. Electro-mechanical drum machines were first developed in 1949, with the invention of the Chamberlin Rhythm 8. Transistorized electronic drum machines later appeared in the 1960s. The Acetone Rhythm Ace, created by Akutaro Kakehashi, began appearing in popular music from the late 1960s, followed by drum machines from Korg and Akutaro's later Roland Corporation also appearing in popular music from the early 1970s. Sly and the Family Stone's 1971 album There's a Riot Goin' On helped to popularize the sound of early drum machines, along with Timmy Thomas's 1972 R&B hit Why Can't We Live Together and George McRae's 1974 disco hit Rock Your Baby, which used early Roland rhythm machines. Early drum machines sounded drastically different than the drum machines that gained their peak popularity in the 1980s and defined an entire decade of pop music. The most iconic drum machine was the Roland TR-808, widely used in hip-hop and dance music. Other classic drum machines include the Alesis HR-16, Korg Mini Pops 120, EMU SP-12, Elektron SPS-1 machine drum, Roland County Route 78, Paya programmable drum set, Lindrum, Roland TR-909 and Oberheim DMX. Sampling technology. Digital sampling technology, introduced in the 1980s, has become a staple of music production in the 2000s. Devices that use sampling, record a sound digitally, often a musical instrument, such as a piano or flute being played, and replay it when a key or pad on a controller device, e.g., an electronic keyboard, electronic drum pad, etc., is pressed or triggered. Samplers can alter the sound using various audio effects and audio processing. Sampling has its roots in France with the sound experiments carried out by Musique Concrète practitioners. In the 1980s, when the technology was still in its infancy, digital samplers cost tens of thousands of dollars and they were only used by the top recording studios and musicians. These were out of the price range of most musicians. Early samplers include the 12-bit Toshiba LMD 649 and the 8-bit Emulator I in 1981. The latter's successor, the Emulator 2, released in 1984, listed for $8,000. Samplers were released during this period with high price tags, such as the K2000 and K2500. The first affordable sampler, the Akai S612, became available in the mid-1980s and retailed for $895. Other companies soon released affordable samplers, including the Mirage sampler, Oberheim DPX-1, and more by Korg, Casio, Yamaha, and Roland. Some important hardware samplers include the Akai Z4, Z8, Ensoniq ASR10, Roland V-Synth, Casio FZ1, Kurzweil K250, Akai MPC60, Ensoniq Mirage, Akai S1000, EMU Emulator, and Fairlight CMI. One of the biggest uses of sampling technology was by hip-hop music DJs and performers in the 1980s. Before affordable sampling technology was readily available, DJs would use a technique pioneered by Grandmaster Flash to manually repeat certain parts in a song by juggling between two separate turntables. This can be considered as an early precursor of sampling. In turn, this turntablism technique originates from Jamaican dub music in the 1960s, and was introduced to American hip-hop in the 1970s. In the 2000s, most professional recording studios used digital technologies. In the 2010s, many samplers exist in the digital-only realm. This new generation of digital samplers are capable of reproducing and manipulating sounds. New genres of music have formed which would be impossible without sampling. Advanced sample libraries have made complete performances of orchestral compositions possible that sound similar to a live performance. Modern sound libraries allow musicians to have the ability to use the sounds of almost any instrument in their productions. MIDI. MIDI has been the musical instrument industry standard interface since the 1980s through to the present day. It dates back to June 1981, when Roland Corporation founder Akutaro Kakehashi proposed the concept of standardization between different manufacturers' instruments as well as computers, to Oberheim Electronics founder Tom Oberheim and Sequential Circuits president Dave Smith. In October 1981, Kakehashi, Oberheim and Smith discussed the concept with representatives from Yamaha, Korg and Kawai. In 1983, the MIDI standard was unveiled by Kakehashi and Smith. At the NAMM show in Los Angeles of 1983, MIDI was released. A demonstration at the convention showed two previously incompatible analog synthesizers, the Prophet 600 and Roland Jupiter 6, communicating with each other, enabling a player to play one keyboard while getting the output from both of them. This was a massive breakthrough in the 1980s, as it allowed synths to be accurately layered in live shows and studio recordings. MIDI enables different electronic instruments and electronic music devices to communicate with each other and with computers. The advent of MIDI spurred a rapid expansion of the sales and production of electronic instruments and music software. In 1985, several of the top keyboard manufacturers created the MIDI Manufacturers Association (MMA). This newly founded association standardized the MIDI protocol by generating and disseminating all the documents about it. With the development of the MIDI file format specification by opcode, every music software company's MIDI sequencer software could read and write each other's files. Since the 1980s, personal computers developed and became the ideal system for utilizing the vast potential of MIDI. This has created a large consumer market for software such as MIDI-equipped electronic keyboards, MIDI sequencers and digital audio workstations. With universal MIDI protocols, electronic keyboards, sequencers, and drum machines can all be connected together. Some universally accepted varieties of MIDI software applications include music instruction software, MIDI sequencing software, music notation software, hard disk recording, editing software, patch editor, sound library software, computer-assisted composition software, and virtual instruments. Current developments in computer hardware and specialized software continue to expand MIDI applications. Computers in music technology. Computer and synthesizer technology joining together changed the way music is made, and is one of the fastest changing aspects of music technology today. Dr. Max Matthews, a telecommunications engineer at Bell Telephone Laboratories Acoustic and Behavioral Research Department, is responsible for some of the first digital music technology in the 50s. Dr. Matthews also pioneered a cornerstone of music technology, analog-to-digital conversion. The first generation of professional commercially available computer music instruments, or workstations as some companies later called them, were very sophisticated elaborate systems that cost a great deal of money when they first appeared. They ranged from $25,000 to $200,000. The two most popular were the Fairlight, and the Synclavier. It was not until the advent of MIDI that general-purpose computers started to play a role in music production. Following the widespread adoption of MIDI, computer-based MIDI editors and sequencers were developed. MIDI to CV gate converters were then used to enable analog synthesizers to be controlled by a MIDI sequencer. Reduced prices in personal computers caused the masses to turn away from the more expensive workstations. Advancements in technology have increased the speed of hardware processing and the capacity of memory units. Software developers write new, more powerful programs for sequencing, recording, notating, and mastering music. Topic: 2000s. Music sequencer software, such as Pro Tools, Logic Audio and many others, are the most widely used form of contemporary music technology in the 2000s. Such programs allow the user to record acoustic sounds with a microphone, mix tracks record or MIDI musical sequences, which may then be organized along a timeline and edited on a flat panel display of a computer or digital audio workstation. Musical segments recorded on can be copied and duplicated ad infinitum, without any loss of fidelity or added noise, a major contrast from analog recording, in which every copy leads to a loss of fidelity and added noise. Digital music can be edited and processed using a multitude of audio effects. Contemporary classical music sometimes uses computer-generated sounds, either pre-recorded or generated, manipulated live, in conjunction or WIKT, juxtaposition with classical acoustic instruments like the cello or violin. Classical and other notated types of music are frequently written on scorewriter software. Many musicians and artists use Patcher-type programs, such as PD, Bejewel, Max, MSP, Kyma, Sound Design Language, and AudioMulch, as well as or instead of digital audio workstations or sequencers, and there are still a significant number of people using more traditional software-only approaches such as C-Sound or the Composer's Desktop project. Music technology includes many forms of music reproduction. Music and sound technology refer to the use of sound engineering in a commercial, experimental or amateur hobbyist manner. Music technology and sound technology may sometimes be classed as the same thing, but they actually refer to different fields of work. Sound engineering refers primarily to the use of sound technology for sound recording or in sound reinforcement systems used in concerts and live shows. Timeline. 1917 – Leon Theremin invented the prototype of the theremin. 1944 – Halim Eldav produces earliest electroacoustic tape music. 1952 – Harry F. Olson and Herbert Bellar invent the RCA synthesizer. 1952 – Osmond Kendall develops the Compositron for the Marconi Wireless Company. 1956 – Raymond Scott develops the Clavivox. 1958 – Evgeny Merzin along with several colleagues create the ANS synthesizer. 1959 – Wurlitzer manufactures the Sideman, the first commercial electro-mechanical drum machine. 1963 – Keo Electronics, later Korg, produces the DA-20. 1963 – The Mellotron starts to be manufactured in London. 1964 – Akutaro Kakehashi debuts Acetone R1 Rhythm Ace, the first electronic drum. 1964 – The Moog synthesizer is released. 1965 – Nippon Columbia patents an early electronic drum machine. 1966 – Korg releases Donker-Matic DA-20, an early electronic drum machine. 1967 – Acetone releases FR1 Rhythm Ace, the first drum machine to enter popular music. 1967 – First PCM recorder developed by NHK. 1968 – King Tubby pioneers dub music, an early form of popular electronic music. 1969 – Matsushita engineer Shuichi Obata invents first direct drive turntable, Technics SP10. 1970 – ARP 2600 is manufactured. 1973 – Yamaha release Yamaha GX1, the first polyphonic synthesizer. 1974 – Yamaha build first digital synthesizer. 1977 – Roland release MC8, an early microprocessor-driven CV, gate digital sequencer. 1978 – Roland releases County Route 78, the first microprocessor-driven drum machine. 1979 – Casio releases VL1, the first commercial digital synthesizer. 1980 – Roland releases TR-808, the most widely used drum machine in popular music. 1980 – Roland introduces DCB protocol and DIN interface with TR-808. 1980 – Yamaha releases GS1, the first FM digital synthesizer. 1980 – Kazuo Morioka creates Firstman SQ-01, the first bass synth with a sequencer. 1981 – Roland releases TB-303, a bass synthesizer that lays foundations for acid house music. 1981 – Toshiba's LMD-649, the first PCM digital sampler, introduced with Yellow Magic Orchestra's Technodelic. 1982 – Sony and Philips introduce compact disc. 1982 – First MIDI synthesizers released, Roland Jupiter 6 and Prophet 600. 1983 – Introduction of MIDI. 1983 – Roland releases MSQ700, the first MIDI sequencer. 1983 – Roland releases TR-909, the first MIDI drum machine. 1983 – Roland releases MC202, the first groovebox. 1983 – Yamaha releases DX7, the first commercially successful digital synthesizer. 1985 – Akai releases the Akai S612, a digital sampler. 1986 – The first digital consoles appear. 1987 – DigiDesign markets sound tools. 1988 – Akai introduces the Music Production Controller MPC series of digital samplers. 1994 – Yamaha unveils the Promix 01. Topic. See also: List of music software. Notes